Hi, everybody. My name is Richard Cromwell. I am a additive manufacturing applications engineer for GoEngineer here out of the Auburn Hills, Michigan office. I run the Additive Manufacturing Lab, and I'm also on the CAM team, so I do both ends of the manufacturing equation, both subtractive and additive. On the call today is my good friend and colleague, Mike Humphrey. If you want to introduce yourself, Mike.
Sure, thanks, Richard. My name's Mike Humphrey. I work closely with Richard here in Michigan, and we're basically the Midwest additive team as it stands right now and cover the Great Lakes states. And thank you for joining.
Yeah, thanks for taking the time, everybody, to join us today. I hope to share with you what I've been able to learn about an exciting new material that Stratasys has just recently released called ABS-CF10. And so we'll just get into it. So the market challenge that we're trying to solve here is primarily in the manufacturing realm. And so manufacturing tooling is heavy. It's made out of metal. It's expensive to machine. The prior 3D printed fixtures that you might have tried to use in the past, maybe made out of like ASA or PLA or some other type of plastic, they would break and they would lack the required stiffness that you would need for tooling jigs and fixtures. Frequently, if you did make a cool tool, they would often be removed from the job sites. They would also have a high demand cost. People would want to use them. Traditional methods of making tooling have a long lead time. Everybody knows this. Machining a jig can take weeks of lead time to actually get it up onto the CNC. And that can be a pretty big bottleneck in the manufacturing process. And then also there are limited options because you're designing for manufacturability when it comes to these jigs. And that can limit your geometries as well as some of the ergonomic needs that you might have. So what if manufacturing aids, jigs, and fixtures could be lightweight? What if 3D printed parts were durable with appropriate strength and stiffness? What if tools were cost effective to produce? And also, what if complex geometries and functionality could be easily achieved? What if we had a material that was a 3D printed carbon fiber? What could we make with it? We could make end use parts. We could use it for a variety of tooling and work holding applications. Parts used in the production of end products. Robot end effectors are a really popular utilization of the technology. And then inspection aids and CMM aids, we can make functional prototypes that can withstand some load. Ergonomic aids, where you're not limited by the manufacturability, and much, much more. So as the solution, Stratasys is introducing ABS-CF10, which is a ready-to-use FDM carbon fiber-filled thermoplastic material. ABS-CF10 unlocks the potential of carbon fiber reinforced thermoplastics on the easy-to-use F123 printers by delivering stronger, stiffer, and lightweight parts. Now, ABS-CF10 is 15% stronger than traditional ABS and 50% more rigid. So we have 10% chopped carbon fiber by weight in this material. And basically, ABS-CF10 provides extra performance from the lower cost material as opposed to jumping up in cost to a bigger Fortis machine and say printing with some of the higher end engineering thermoplastics like nylon 12 CF or like the PEC-based Antero. So this is the first fiber reinforced material on the F123 series. One of the things that I really like about this material is that it can be easily used with additional fixturing needs and requirements such as metal inserts. You can see here that this operator paused his print at a certain Z level and he's inserting metal components, and then he'll end up printing on top of those. So that's a way to give yourself really robust threads. You have, with ABS-CF10, 3 slice heights, 7 thou, 10 thou, and 13 thousandths of an inch, all with the same head and the same tip. You don't have to change anything. The extrusion is controlled by software. And now here's a really big one. This uses QSR soluble support for hands-free support removal. And I'll show you guys how this works, but it's a fast dissolving support material. It allows engineers to leverage true design freedom and geometric complexity that additive manufacturing allows. And another great thing is that QSR support is compatible with several of the other F123 materials. So whether you're printing an ASA or ABS-M30 or ABS-ESD7, and we'll talk about these other materials in a little bit, but you don't have to change the support. You only have to change the model material. And that's pretty great time saving, especially in a situation where you're using these printers in a manufacturing environment or engineering office where it's a shared printer. And that way you don't have to worry about going and changing the support just because you want to change the model material. So ABS-CF10 is available on the Stratasys F170, the 270, and the 370 printers. There is something called the F120 that's more of a classroom printer. That's not included for this material. But a material is only as good as the platform that delivers it. And so we're going to talk more about some of the mechanical properties of ABS-CF10 in a minute, but I want to talk about the actual machine just briefly and give you a high level overview of what these machines are capable of. And so first and foremost, the software that these systems utilize is GrabCAD Print, which is Stratasys' proprietary slicing software. It's extremely user-friendly and easy to use. Accuracy of details and repeatability of complex geometries. This is a very accurate system that can do repeatable prints over and over and over. It is really a small little production system here. This machine does have a fast draft mode, so you can print rapid iterations of a design for fit and function before you go for something that you really want to get a good surface finish on. It has a relatively large build envelope, especially considering a lot of the other desktop style composite material printers. Now, I mentioned that with ABS-CF10, you have the 7 and the 10 and the 13 slice heights, but the machine is capable of getting down to a 5 slice height with some materials, and that gives you an incredible surface finish on the Z height. You basically can't see the layer lines. The machine has an intuitive interface. It has a touch screen. Just turned on the light in there. All of the calibration and setup and all the things that you have to worry about with other printers, like printing temperature towers and all those kind of things, you don't have to worry about with this. It does it all for you. It has its own little wizards that you run through to calibrate the machine and set things up. There is an internal camera. It's up here in the corner. And I use it all the time because you can do mobile monitoring. You can monitor your prints from your phone. Now, another very important thing is that this machine uses standard build trays across all materials. And when you have a printer that's sharing with other people and you're all printing different things, eliminating that variable of having to deal with different build trays for different materials, that's a real time saver. And so the trays are like this. And you just pop them in and out. And it prints a layer of support material first. And you can reuse these over and over and over again. You can just either scrape this off. So you can get a lot of prints out of one tray. And it's really easy also to just pop the tray off. I have a part that's on here and it's ready for removal, okay? I printed this overnight last night. And it's just like a little aerospace bracket. And see how easy that came off? You basically just push down this lever, this thing pops off, and then you can put another one on, and it's basically ready to print again. It'll ask you, is the tray ready for another job? And you just hit yes. And also what I like about this machine is it's smart enough to know when it's been opened and if it's empty, and it asks you these questions to make sure that if I leave it in ready for part mode, which you can activate from like the settings screen, that I can then initiate a print from anywhere. I have a habit of initiating prints from my kitchen table on this machine because of that ability. So once you remove a model from the build chamber, you can just basically peel it right off. And then we'll save this. for another time. And so this printing it in this orientation I did for a reason. I wanted to have all this support material in here because I wanted the surface finish. This is kind of like an angled bracket, and I didn't want a lot of steps on this elevation here as it goes up. So I printed it like this. Now, if you did this on some of the other composite model printers, you would have a hard time cleaning that out. I'll show you guys my wall of parts real quick. I'll just go by it. I spent a lot of time printing lots of parts, but most of them I can't put on the shelves because they're actually for customers. So here is, as they say on cribs, where the magic happens. Just kidding. This is my post-processing room. And this is my ultrasonic cleaning tank that I would use for cleaning support material off of my model. So now I'm going to take my part that we just pulled off the printer and throw it into the basket, lower it down, and close it. And in about 45 minutes, we'll pretend like it's a cooking show, and through the magic of television, I bring you a cleaned part, okay? Now, I would take this out of the bath and rinse this off in clean water. I have a sink back there, maybe for about a minute. And then I would put it into a drying rack and just let it dry. And then we have a completely usable part. So that's pretty simple. And it's not like you have to just spend tons of time chipping away at breakaway support material. The boxes that this material comes in kind of look like this. And then when you open them up, there's a bag that is vacuum packed here. And then you have the roll inside, and you can see that there's desiccant on the inside of the roll to help keep everything dry. And then there's also a EEPROM chip that interfaces with the machine. So the machine always knows how much material you have on a roll. So you can't like initiate a print that you don't have enough material for. Now, some other things that we've been able to print are some of these things. The additional stiffness that the ABS-CF10 provides gives you the ability to make some pretty neat geometries, especially when you take into account the soluble support. So you can make things like this little shock absorber. This is a alignment gauge. This is really light. If you made this out of aluminum, it would probably weigh 50 to 70% more. And then also you can do neat things like incorporate part numbers or instructions. I don't know if you can see that, but there's the part number on there. And look at that surface finish. That's pretty great. The layer lines are not really, you can't really see them, especially on the Z axis. But if you look at the XY, it's usually a little bit rougher. Not on this part. This part's really great, but a little bit. Like I have this one. So I like this little nozzle a lot because you can see the threads and the angle of the threads, and it has a really nice surface finish. But characteristic of ABS-CF10 is that because of the chopped carbon fiber infill on the XY, it does look a little bit rougher, but overall the print quality, the part quality is really great. Like ease of use is one thing for the F123 series, but the other just as important, if not more so. It doesn't matter how easy something is to use if it doesn't do what you want it to do. This thing is incredibly reliable. Stratasys did a test with 45 dimensional accuracy parts printed on 3 different Stratasys F370 printers with over 1,100 geometric measurements. They had 99.9% of their parts had accuracy within 10 thou. And that's pretty phenomenal. They actually did another test that I remember Stratasys discussing not too long ago, where they had compared the F123 series versus a lot of the desktop composite printers, and they gave the Stratasys machines 100% score for reliability, and the nearest competitor was at 72%. And so these are machines that are professional grade printers that were invented by the people that invented FDM printing 30 years ago. And you can tell that they've continued to push the envelope and make this technology more accessible and superior. Another thing that is great about these printers is that you have a really robust software ecosystem to help you get your projects from the engineers into the printer and then back into their hands as a finished part. And so GrabCAD Print is the slicing software, and it reads native CAD files. It connects to the Stratasys printers, and can also increase productivity with print management software. They have GrabCAD Shop now, which is a really powerful tool for helping you manage all of the different print requests. The whole ecosystem for the software, that can be a whole webinar on its own. And so we'll leave it at that. I want to talk briefly about some of the other materials because that will help us put ABS-CF10 in perspective, like where does it fit in the lineup that Stratasys has. This is important because like a lot of those other desktop composite printers, they can only print essentially in these nylon-based different composites, where the Stratasys system gives you a tremendous amount of flexibility. So we'll show you some of these materials. ASA, I've kind of talked about it a little bit. It is the go-to printing material. ASA is a good way to go because it has a lot of excellent surface finish. You can do the full gamut of layer heights from 5 all the way up to 13. It uses soluble support, and it comes in a lot of colors, which is nice too. And that's not just for aesthetics, but for function. If you can color code tools on a factory floor, you know, keep them in different departments. The red ones go over here, the blue ones go over here. That can really help you out. ABS, this was the material that people really would print in most of the time before ASA came out. ASA has some additives for UV stabilization. You can put it outside and it doesn't degrade, where ABS, really not for that. PLA, I want to do a whole webinar on PLA on the F123 series because I think it's a little bit misunderstood. A lot of people think of PLA as a hobbyist level thermoplastic. However, because of its low melt temperature, it means that you can print it super fast on this machine. It doesn't use soluble support. It uses breakaway support like you kind of expect with PLA, but it allows you to do really fast, low-cost iterations of models, and then a lot of conceptual prototypes. I also think that it's really great for classroom settings because it's really inexpensive. ABS-ESD7 I have some right here. It's just a little piece. This has electrostatic dissipative properties, but it has an ABS-M30 base. This is really great for electronic housings. PC-ABS, a very strong material. It gives you the best of both worlds when it comes to ABS and PC. You have high impact strength. It's a good, durable thermoplastic, and it gives you a nice finish quality. It's good for conceptual models, functional prototypes, manufacturing tools, production parts. Here's one of my most favorite materials, the FDM TPU92. This looks familiar. This is a elastomer that you can print. And you need a separate head to do this, but it still uses the QSR support. So if you have seals or vibration dampeners, protective covers, this is a great material. And again, all of these can be printed on the F123 series. Duran, now this one's for the 370. It's like a nylon 12 with 7% mineral infill. It has a very smooth surface. This is really terrific for, let's say you're making a jig and you have finished surfaces that are going to make contact with the jig or the fixture. The touch points can be made out of Duran, and that's just a really great utilization of it. It does use a breakaway support though. It doesn't use the QSR soluble support. So you have to take that into account when you're designing for that part. Where does ABS-CF10 fit in? And this chart is primarily geared towards like the manufacturing environment. So if you had all these materials that we talked about, you know, ASA is great for inspection tools. ABS is good for low requirement tools. The PC ABS is for the impact resistance. ESD7 for the electronic components. because of the electrostatic dissipative properties. The TPU is great for soft touch parts, like we said. The Duran is good for alignment tools on finished parts or to protect surfaces. And then we finally come to ABS-CF10, which is great for alignment tools, end effectors, and ergonomic aids. I like the end effector thing because you can actually put pneumatic channels inside of the design, and they're so much lighter, giving you a lot more productivity out of the robots. How does it compare to other materials in the F123 series when it comes to stiffness and strength? ABS-CF10 has the highest stiffness of any of the materials on the F123 series, and it's just under Duran for ultimate strength test. So let's say if anyone already has a F123 series printer, what do you need to get started printing in ABS-CF10? You would need a roll of ABS-CF10. Like I said, it comes in 90 cubic inch rolls, which is great. You would need an ABS-CF10 hardened head. Now this is optional because I was on the beta, the head wasn't even released yet. And so I just ordered a new head, and because of the carbon fiber, it's going to chew up the inside of the print head faster. So it degrades the lifespan from 1,500 hours to about 800. The solution is to just buy one of their hardened heads and dedicate that to ABS-CF10 printing exclusively, and then you can run everything else on your other head. And then the last thing you need is just a free software update. We're running out of time here. I want to wrap things up. But I just want to remind everyone that whatever your 3D printing needs, tech support for 3D printers that you acquire, 3D printing training. We have our application engineer mentoring sessions where we can walk you through different applications of the technology. And then we also have a full service bureau, like a print apart service, where you can send us your geometry and we can print it out for you. And that's a great way to test different materials and technology before actually acquiring a system for yourself. All of this kind of stuff, including more resources, you can go on and buy consumables, all the things that you need for your 3D printing. You just go to GoEngineer.com. And so thanks, everybody. This has been Richard Cromwell from GoEngineer. I want to thank everybody for taking the time today. You can email me at this email address. You can also find me on LinkedIn. I encourage you to go to our GoEngineer's YouTube channel, where we have hundreds and hundreds, probably thousands of videos on everything from SolidWorks to CamWorks, Altair software, Stratasys 3D printers. And we also have the Velo 3D, metal 3D printing systems, exact metal. So whatever you need, just head on over to GoEngineer.com.